And here we go, guys, the very first question of the S1 June 2017 paper. So what do we have here? So it states that a closed shop manager records the weekly sales figures pound S and the average weekly temperature T degrees Celsius for 6 weeks during the summer. The sales figures were coded such that W equals S over 1,000. So what this means is that for 1 unit of W, we should get 1,000 units of S. If we had to just do some little math rearranging, yeah? Or 1 unit S, you get 1 over 1,000 W. So the data are summarized as follows. So you're given the usual stuff. You're given the sum of squares for W, you got the sum of WT, and so on. Now, simple sum of squares regression. Find SWT and SS and STT. So SWT, using just the standard formula, it will just be the sum of firstly WT, like they want, minus the sum of W times the sum of T, all over the number of weeks, so over 6. Easy. Now you should get, so you're just going to simply use this value here, this value here, and this value here. So plug that into the calculator and just multiply them out. So it's going to be 784 minus 42 times 119 over 6. And I got minus 49, so this equals minus 49. Now, as for the second one, STT, so I might just do it up here actually, save some space. It's going to be similar, so it will be the sum of t squared. Usually you're told to usually find each of these sum of squares or sum of variables, but here it's pretty lucky. So it'd be the sum of t times the sum of t, or you can write sum of t squared over 6. So again, now in this time you're going to use the sum of t squared and t again, so just these two variables. Okay, so have a go. So I usually write like this just not to make it the mistake of using the same value, same sum of t squared. It's better you just write it in parts just like you did for previous to avoid error. So what do you have? So you got 2435 minus 119 times 119 over 6. And well, I got a mixed fraction or an improper fraction, so I'm going to use the result of 449 over 6. Okay, you can use the variations to that, that's fine. Right, part B. So write down the value of the sum of squares of SS and ST. Okay, this one's a bit different because you're not actually giving any data about SS or S in general. In fact, the only thing that's relevant is the coded value here. And yes, we do need to use this one, as the key idea is to just manipulate this one and use it as a substitution. So first things first, let's make S a subject here, yeah? We should get S equals 1,000 worths of W. Now, one property of the SS is that it kind of works like variance. The sum of squares means we need to find a squared multiplier for this expression. Since we know that SWW here is 50, this SS would be 50 times the square of 1,000, because that's how it works. The sum of squares is the squared expression. So we can say instantly that means SSS would be 1,000 squared times SWW. So more or less fits the pattern. And doing that, let's see, you should get, was it 1,000 squared times 50? And you should get, what's that? 50 million. Yep, so you should get a result of 50 million. Okay, and as for ST, well, this is a single square because it's not, there isn't two S's, it's just a single ST. We already have one of the similar variables. We have WT. WT is minus 49, so it's got the same position. So instead of W, we do the same idea. We know there's for a single S, it's 1,000 W's. So instead of multiplying by 1,000 squared, because there's two of them, it'll be one of them. So it'll just be ST times equals 1,000 worths of SWT. So for a good mental recap, if you're using the same letter twice, then it will be a squared version. But if you're using a single letter with a known value, it will be once. So it'll be power 1 because there's only one change in variable. And doing this should give you minus 49 1000. And that's it. All good. Now, as for the final part, the product moment correlation coefficient, this is just a standard regression parameter. So it'll be R equals, our correlation parameters will be R equals the sum that we're trying to figure out, so S and T, over the square root of the combined variables, so SS and STT. So that's the idea to look at. When you say it's between S and T, throw S and T at the top and then find the combined ones underneath and square root them. Now, we have everything, don't we? ST is minus 49,000. SS, where is SS? God, I should, yeah, so SS is 50 million, so that's going to be long to write. You can write this in standard form, actually, it might be better. And STT, we found right at the top, is 449 over 6. Okay, and then, yeah, you square root this. And in doing so, I should really calculate this in advance. You should get square root of 50 times 449 over 6. I got about minus 0.801. So minus 0.801. So you can see that the result is a highly negative correlation, and it's almost perfectly negative. Not yet. If it reached -1, it would have been. So we'll probably have to make a conclusion on the next parts. Okay, here we go. So part D, E, F, and G. So the manager of the closed shop believes that a linear regression model may be appropriate to describe these data. So what I did, I went ahead and just copied all the relevant pieces of information data that's required for the next four problems. So now part D, state, given a reason, whether or not your value of the correlation coefficient, i.e. the R value we obtained here, supports this manager's belief. Well, according to the manager, he believes that a linear regression model may be appropriate to describe his data. So one thing about linear regression model, when we look at the data set itself, this value here of R is telling us that it's strongly negative. So it looks like it's almost perfectly negative. So this means that the data points around this are all fitting that line, if we had to draw it. If we drew the negative correlation, it will look a bit like this. And the data looks kind of like this. So this is telling me that the line is pretty much straight, it's linear when we do the line of best fit. So yes, it supports. Also the fact that if it was, for example, less than 0.5 or like somewhere around 0, it would be no correlation. So technically, a line of best fit wouldn't make sense. Hence, a linear regression model wouldn't make sense either. So stay given a reason. So we'll say yes, because R is close to -1, and this supports the method. And you can also stay as well, if R is less than 0.5 or around 0, then it wouldn't make sense to draw a line of best fit, so it does not support it. Okay, E. Find the equation of the regression line of W on T. So this is very important, W on T. Given your answers in the form of W equals A plus BT. So first things first, let's figure out the value of B. W on T means we find the sum of squares of W and T and all over the total T. That's how it usually works. Now you just plug in the values. So SWT is -49, STT is 449 over 6. Let's smash that calculator. And you should get, so I got, well, the three significant figures, minus 0.655. I would keep this answer in the calculator for part A, yeah? So don't delete the answer yet. So again, so let's do part A now. Let's do the value of A. One way to work out A, which is very convenient, is that you could just rearrange this regression equation, make A the subject, so it'd be something like W minus BT, and just stick a mean sign on both B and T, W and T, and that's it, you've done it. Now you're officially estimating the value. So the mean of W is straightforward, it's just the sum of W, which is 42 over N, which is 6. So writing on the whole thing, it would just be 42 over 6 minus the value of B, which we already have on the side, times T, which the mean of T, which is 119 over 6. So keep this B in your calculator, so just use the answer button, yeah? So it'll be 42 over 6 minus answer times 119 over 6. And Well, you get an answer which is pretty much close to 20, so you could even say about 20.0 to three significant figures. That's what they do in a mark scheme. Generally speaking, you could write all those digits, but it's unnecessary. And yeah, I think that's really it. So let's look at E and F. So we've done E now, so this means that if I was to write the equation formally, it would be W equals A, which was about 20.0 plus, no, minus actually 0.655 t. Now F is very similar. Hence find the equation of the regression line of S on t. So S on t, so it looks a bit similar, giving your answers in the form S equals C plus dt. So the only difference here is that W is now replaced with S. And we can just figure this out using the relationship of the coding here. Technically, all you can really do is just make S a subject here. If you do that, you get S equals 1,000 worths of W. And well, if you just replace W with your equation, you just multiply the whole equation by 1,000. So it just literally be 20,000 minus 655t. And that's it. That's really all you do. Okay, and lastly, part G. So using your equation in part F, so this is the S on T equation, interpret the effect of 1 degree Celsius increase on average. So this is when T increases by 1 on weekly sales during the summer. Okay, so first let's understand what this equation means. We have S equals 20,000 minus 655t. Now, just looking at this, the 20,000 appears to be constant, so we can say that there are fixed weekly sales of £20,000. So this is the fixed weekly sales, right? And now, as for this equation that represents T, we can say that for every 1 degree Celsius, there's a decrease of £665. So you can say decrease of £655 for every 1 degrees Celsius increase on average, blah blah. And that's it. I believe this summarizes the whole question. So let me know how you guys did and leave a comment if this was helpful. But yeah, otherwise, I shall see you guys soon. Yeah. So what do we have here? So it states that an estate agent is studying the cost of office space in London. He takes a random sample of 90 offices and calculates the cost X pound per square foot. His results are given in the table below. So first things first, for every type of question, we should always record the end value of n. So we can say here that we have a total sample size of 90. Or, according to this table, a total frequency of 90. You could use both here. Okay, so they're both the same. Alright, now you're given some more data. You're given the midpoint value of y, so they've already done the midpoint for us, which is nice of them. And they've already gone ahead and calculated the sum of f times y squared. So they calculate y squared here and just multiply them across and found the sum of it. This would be useful for calculating standard deviation and variance and stuff. Anyway, back to the problem. Now, a histogram is drawn for these data, and the bar is representing between 50 to 60 is 2 centimeters wide and 8 centimeters high. Calculate the width and height of the bar representing 20 to 40. So my advice, for every histogram-based question, I would just draw a little sketch on the side and just label the x-axis the class width, representing in this case the cost, and the vertical and the y-axis the frequency density. This represents the height in this sense, yeah. And then if you think about the area or the bar inside, this will be the frequency. So we can think of it like an area rectangle. We can say that the class width base times height equals area, or class width times frequency density is frequency. So this formula I always relate when I do histogram questions. I recommend you put this down. This is very useful. Now, for example, y. If we look at the cost, let's go ahead and evaluate the class widths here. What do we have here? So we have a class width of 20. Here we have a class width of 5. So just find the differences. Oh my god, I'm so slow. 5, 10, got my 5 so ugly, and 20. So now, and then we just make an extra column, we call it frequency density. Now, using this formula, let's calculate the frequency densities of all of them, why not? So we could say first things first, frequency density equals, using the formula, it will just be frequency over class width. So this is just simply frequency over class width. So in your calculator, the first one would be 12 over 20. Keep as a decimal, yeah? Get 0.6, 13 over 5, 2.6, and so on. So keep doing this until you get all the relevant results, yeah? 8, I think it's 0.4, yep. Okay, now that's useful. So the whole point of this is that these are just units, right? And we're given some information in centimeters. So I always use ratios now to figure this out. This is such a useful method. We compare units to centimeters. So what do? So we can say that for every, let's have a look. All right, so let's just discuss the 50 to 60 bar, yeah? We can say for the 50 to 60 bar, for let's discuss firstly the frequency density, the height, yeah? This is the frequency density. We can say that for every 3.2 units of height, this is equivalent to a height of 8 centimeters. So first thing first, just find what 1 unit is divided by 3.2. It will just be 8 over 3.2, which is 2.5. So every 1 unit is 2.5 centimeters of height. Meaning, if we're going to calculate now the 20 to 40 region, which is 0.6, so that means 0.6 units times that by 0.6, and you should get 1.5. Done. So 1.5 centimeters represents the height. As for the width now, let me change to red. We do the same thing and for width. So we've got units to centimeter. So according to the 50 to 60, for every, where's the width? Okay, the width is the class width here. So for every width is 10. 10 units represent, according to the data, 2 centimeters. So it's quite easy. So for 1 unit, this is going to be divided by 10, 0.2 centimeters. Meaning, for what we want for the 20 to 40 region, for 20 units, times it by 20 and you get 4 centimeters. And that's it. The width is 4. Easy. That's how you do this kind of question. Okay, here we go again. So looking at this worked example, we're going to look at part B. So that's going to be use linear interpolation to estimate the median cost. Now, firstly, what is the median? The median is actually the middle person or middle value of the data set. First things first, we look at the frequency and we know straight away that the total should be 90. It's technically given. And we know that the median lies somewhere in the middle. So it should be the 45th. Or you can also say n plus 1, 46th person. Either way, you'll get the same result or about the same result. So how do we do this? To use interpolation, firstly, we just draw a nice line all the way across. And first thing, I'll label the median here. Now, what do we put in all these values? Well, let's look at the table for a second. We want to firstly find where the middle person lies. So let's count the frequency and find where the 45th person is. So at the frequency, we've got 12 here. Use cumulative frequency, so add 13 more, there'll be 25 up to this point. Add another 25, there'll be 50. So up to this point, the median should lie somewhere in this interval. So we can instantly say that the median is somewhere between 45 and 50. Now, for the bottom values, this is just the position. So the median's, of course, the 45th or 46th position. I'll use 45 for this example. You can use 46 too. And for the lower and upper bound, we could say that he must lie between the 25th person here and the 50th. Okay, now we've done everything. So now all we do is, interpolate. So to do this, we look at the top and lower values and we just find proportions. For example, we can say that the difference between the median 45 is proportional to the difference between the first two positions. So let's say that. We can say m minus 45 is proportional to 45 take away 25, yep. And we can say this is equal to, and we pick another range. We can say that 50 take away 45 is proportional to 50 take away 25. So this line could be the kind of divisor, yeah. So 50 minus 45 is directly proportional to 50 minus 25. You could do this in various ways. You could do upside down. You could take long waves. You could do m take away 50. It doesn't matter. Ultimately, you'll get the same value because this is all in direct proportion. Now let's go ahead and resolve this, yeah? So resolving this one, you get M45s over 20 equals 5 over 25. So times 20 across and add 5. Let's see what we get, yeah? 25 times 20, add 45. And I got exactly 49. So M equals 49. So within this group, the total cost for him, the median cost was £49. You can probably get other similar answers like £49.10 or £49.11, but all these answers will guarantee you 2 marks. Okay, here we go. Part C and D. Now here we need to estimate the mean and the standard deviation for this data. Now, I've already gone ahead and put the n is 90 as usual, and now I've added the sum of fi. And the way this is calculated is that we first need to multiply the frequency with the midpoint y, so f times y, and then just add them all up. So multiply all of these and then add them up all together. You should get this result. Now, let's go ahead and actually solve this problem. So to calculate the mean, which is quite straightforward, it's just the sum of fy, the total you have, over the number, which is 90. And this will just give you 4420 over 90. Should give you exactly, well, I'll keep it to a decimal, 49.11 recurring, or you can leave it as a fraction. So that's the mean cost. So the mean cost, actually, you know, we should put in pounds. So the mean cost is £49.10. As for the standard deviation, well, I usually use this relationship. I always use the variance relationship. That is the mean, or the second moments minus the mean squared. This is always the best thing, and then you just square root this. So this notation, this literally means firstly find this expression, but instead of fy it will be fy squared, and we have it. Ex squared is simply the same thing. Instead of y it will be squared over n, and the mean we already have, be fy over n. Then you just square root. So quite straightforward. Always use this relationship, it's so much easier because it's the same expression, and then you just square the mean. So what do we have? So it would just be, it's a long one. So in your calculation, it would be 226 and then 687.5 over n, which is 90, minus the mean. So it would just be your answer squared. So the mean as a fraction was actually 440. Well, let's just keep the whole thing. 90 squared. Sometimes it's better to have exact answers. So do that in the calculator and you should get something decent. I'm going to quickly calculate, yeah? 687.5 over 90 minus squared. Yeah, and my standard deviation was, let's see, 10.33 pounds, 10.34, go round it up obviously, 10.34 pounds. So that is the spread. Actually, one more note. For some reason, I rounded the mean to 3 single figures. Just keep it as 11. I think that's the best answer. Just keep it into 2 decimal places, not 3 single figures. Anyway, that's all, guys. Okay, here we go. Part E and F. So, describe, given a reason, the skewness in relationship to a given mean and median. So, have a look at both these values. We can instantly say that the mean is roughly equal to the median. What does this mean? If you got the center, the mean, which is all of the values, and the median, which is the absolute middle of all the population, and they're about the same, this means that you're looking at a symmetrical data set. So just think of it like this. Let's just do a data set like this. This is the median of the whole data set, and it's also the mean. This means that the amount of values from both sides are going to be identical. So they're both the same. So this is, we just imply that it's symmetrical. Because of this, we can instantly use something known as the normal distribution. Because again, this is also symmetrical about the mean. And that's it. So we can pretty much say that the mean is roughly equal to the median, so therefore it's symmetrical. That is the skewness of the data. As for part F, let's have a read. So it states that Rika suggests that the cost of office space in London can be modeled by a normal distribution with mean 15 standard deviation. With reference to the answer in part E, comment on Rika's suggestion. So like I said earlier, a normal distribution is symmetrical, yeah? So this is symmetrical. And because of this one, it's always balanced on both sides. So again, but thankfully the mean is also centered in the middle. So hence, all you have to say that is because it's symmetrical, a normal distribution is a totally valid choice. And that's it. Okay, here we go. Normal distribution. So Rika suggests that the cost of office space in London can be modeled by normal distribution with mean 50 and standard deviation 10. So first things first, always say that X is normally distributed with a mean of 50 and a standard deviation of 10 or variance of 10 squared. Okay, that's how we always write this down. So it's always in the format of mu and sigma squared, where mu is the mean, sigma is the standard deviation. All right, we're going to ignore F because we've done it previously in a different video or earlier. So use Rika's model to estimate the 80th percentile of the cost of office space in London. So what this actually means, the 80th percentile, this is telling us that all the data up to 80%, up to a certain value was 80%. In terms of normal distribution, this is the function at some 80th percentile, and it must have equaled 80%. That's how we begin it. This is actually a cumulative frequency and can also be written as the probability of x less than or equal p, which equals 80%. The key idea here is to simply look at the table for the 80% value and then simply just match it with the inside of this. But to do this first, let's rewrite this as the correct normal distribution format. So this would be probability that z is less than or equal than p minus the mean, which is 50, over the standard deviation, which is 10. And again, this equals 80%. And the value inside the table, which corresponds to 80%, the z value is equivalent to that. So first, let's have a look at the z value, the table, and find the 80% mark. So according to this table, we have to find where is 80%, or in this case, we need to find 0.800, or the closest. So the closest one I can see, it's around here. You won't find it, but it's super close. This seems to be the closest value, 0.7995, and that corresponds to the z value of 0.84. So 0.84, that cross references. So going back to the table, so this means this equals to roughly 0.84-ish. It's kind of hard to get because it's very tight. So then we just say, therefore, all of that value, p minus 50 over 10, must equal 0.84. Then you just solve it. Times 10 across, and then add 50, and you should get about so about 50 so, yep, so 58 pound 40-ish, three significant figures, yeah, because that's all we can do. And that's it. So this represents the 80th percentile, so this is ahead of the mean, yeah, so it makes sense. If this was on a bell curve, if the mean here is 50, the 80th percentile, and this is also bang in the center because it's according to the model we saw before, the median for this case is also the mean. This was in reference to part F, and the percentile is around here, 58.4. And this looks like, I don't know about you, but this looks like an 80% mark, and this is probably just a little 20%, which is values greater than, yeah. So up to here, up to 80%, this manages up to 80% would be 58.4, and that's it. That's what we need to know from here. If you've got any questions about how to deduce for any other problems, always first write the function of p. So this is the cumulative function up to the percentile. That's equivalent to x less than or equal p. And then you just work your magic and you should be done. Anyway, guys, see you. And that's it for question 2. And if you enjoyed it, leave a like, subscribe, and I'll see you in the next one. So we've got a Venn diagram, a triple one, which shows 3 events, A, B, and C, with each of their respective probabilities, yeah? Now, according to this statement, it says the probability of A, as in the whole of A, is 0.5. So we can say instantly that R plus S is 0.5. Okay, that's basically everything in A. Probability of B would be the same, would be S plus T plus P. That must be 0.6 because we're including the whole of probability of B that occurs. And probability C, as in P and Q, must equal 0.25. So P and Q is 0.25. We can also know a couple things. It says the events of B and C are independent. Okay. When they tell you this instantly refers to the statement that the probability of B times the probability of C must equal the intersection point. So probability of B times probability of C equals the intersection point, in this case P, yeah? Now, let's look at this one more time. So since we can already solve some things actually. We can see that the probability B is 0.6 and C is 0.25. Let's smash that in the calculator right now. So 0.6 times 0.25 will give you 0.15. So you can just replace P with 0.15. Okay, so just make it easy for yourselves, yeah? Now, since we got 0.15, we can work out Q, because the whole of C must be 0.25. We have 15. There's obviously 10 left over, so 0.10. Alright, so that's good. Let's try and find the rest of them. So we also have the 0.08 here. So always make sure you want to know like what's exactly outside the Venns. If there's 8% outside, meaning all of this must equal 92, 0.92. So let's make that sum here. So we got R plus S plus T plus, well, P and Q. So now we got P and Q, which is 25. And all of this must equal 0.92. So just doing some quick math, subtracting 25 across, we should get 67, yeah? So we can say R plus S plus T equals 0.67. Okay, so far so good. Now, what can we do from here? So here we just go do some, just solve this simultaneously. So we need R, S, and T. So if we just look in the first set of equations, the property A1 especially, we can see that R and S automatically gives 0.5. So these two is 0.5. So now we got 0.5 plus T is 67. So subtracting 0.5 across, you should get 0.17. Easy. And again, the whole of B we know equals 0.6. So sum these up and subtract it from 0.6. So you got 17 plus 15. 16 minus answer will give us 28. So S is 0.28. And of course, R is the same thing. The whole of A equals 0.5 or 50. 50 take away 28 will give us 22. So 0.22. Easy stuff, guys. Very easy. So that'll be A, B, and C done. Now, D is an interesting one. It says state giving a reason whether or not the independence A and B, whether or not the events A and B are independent. So just like the definition for B and C, we need to check if the probability of A times the probability of B will give us 0.28, will give us the intersection point between them. This is the intersection point. So go ahead and smash these two values in your calculator. So 0.5 times 0.6, and what do we get? Well, we get 0.30. And the problem with this one now is the fact that it's the answer should have been 0.28. So the answer would be, no, it doesn't equal 0.28, so it is not independent. Okay. Now, final question. So find the property B given that we have the union of A and C. So with these given that questions, always look at the given that part. So A and C means we only include the whole of A and the whole of C. Meaning for the whole Venn diagram, we can ignore every other value that is in A and C. So this means now our total sphere that we're interested in is going to be everything in A over everything in C. So that is so far the total overall probability. Okay. However, we want to find the B part in all of them. So the B part occurs here and here. So this means that the probability for that happening would be the sum of the B part over all of the rest that I've circled. So in other words, to solve this probability, it will be B over the total probability. So the B part is 0.28 and 0.15. Put down your calculator. So 28 and 15. You should get 0.43. And now the total probability is everything that we care about. We only care about A union C. So all of A and all of C. So all of A is 22, 28, and all of C is 15, 10. So add all these up, and that'll be what goes underneath. Okay, so it's basically like a collection of, so because there's always going to be a new reduced probability. That's how the given that system works. We ignore everything that's not included in the given that. 17 here wasn't included, 8 wasn't included, so you can see the probability is reduced. So yeah, let's put that in. So we got 5, 25. So you should get 75 underneath. And that's it, guys. If you put this in a calculator, well, you get 43 over 75. And that's it. I believe that's the end of the question. So here we've got two tables, a discrete and a cumulative distribution function. So under the discrete random variable x, we're given the following PDF. We know that each of the destinate x values from -1, 0, 1, and 2 were given the probabilities of A, B, B, and C respectively. Now the way the cumulative distribution works, it just takes into account the sum, the total x value up to -1 will give you the cumulative probability. For example, at x equals 0, it takes into account the sum of a plus b, which will give you a solution D, and at point 1 will be the sum of these three will give you the solution of 5, 6, and so on. So the question here we have is two parts. We have A, which is firstly find the values of each of the letters, and the next one is to find the value of this probability when x is squared, which we can make afterwards. For now, let's work out part A. So for part A, let's do it here. Let's call this one part A and part B. So let's have a look. So how do you find, let's try and make some equations. So we can say when probability x equals -1, we get A, and the cumulative up to -1 is a third. So automatically A is obviously a third, because the sum of all probabilities is a third. Up until the second part, we got D. So if we add up A plus B up until x0, we'll get a value of D. So we can say A plus B must give us D. Next one, we got A plus B must give us 5, 6. So we can say A plus 2B's must give us 5/6. All right. And then we got the final one, A plus B plus C, the total. So we have A plus 2B plus C must give us a total value of E, which also gives us total value 1, because remember the sum of all probabilities must be 1. So therefore E as well must be 1. So we can update these values. So we've got A is a third and E is 1. Okay, that's the easy ones. Now, let's start plugging in the values we know. So because we know A is a third, if we plug into this third equation, we're going to have 1/3 plus 2B equals 5/6. So this becomes 1/3 plus 2B equals 5/6. And now if you subtract a third and then divide it by 2, you should get B equals 1/4. Okay, so I did this previously, so you should get this kind of result. That means this one's also 1/4. That means the sum of C, which equals 1, so we need to subtract 1 from all of these terms, from A and 2B, to get 1. So C will give us 1/6. Remember, the total is 1. And that leaves us with D. And D is clearly the sum of the first two terms, a third and 1/4, which will therefore give us 7/12. Alright, now, as for part B, finding the probability value of x squared when it equals 1. So all we really do is, because it's a probability, it's going to be a discrete random variable. If it was a function, it would be in this table. So because we're doing x squared equals 1, we need to make a new variable here, call it x squared, and then square every single value here. So the square of -1 will be 1, the square of 0 is 0, 1, and then 4. Because we want the probability to equal 1, we're concerned about these values here. Okay, so we're concerned about the probability value of these two. So this clearly tells us that when x squared equals 1, it could either be a third or a quarter. And that's it. So the solution would be a third, or in this case plus a quarter, since these are the only options. And that should round up to, or total, 7/12. And that's it, guys. I mean, I hope this video helped. And if you've got any more questions, let me know. Otherwise, I shall see you in the next question. Ciao. Now, Yuto works in the quality control department of a large company. The time T minutes it takes Yuto to analyze the sample is normally distributed. So now we know exactly what distribution is, with mean 18 and standard deviation 5. So before we answer any question, always write the distribution at the top. So we can say let T be normally distributed with mean 18 and standard deviation 5, or variance 5 squared. Now this, just to make it clear, this is represented as mu and sigma squared, where mu is the mean, sigma is the standard deviation. Okay, now let's answer part A. So find the probability that Yuto takes longer than 20 minutes. Now this is just simply probability that the variable T for the minutes is longer than 20. That's exactly what they want us to find. Now the only way to solve this is that we need to convert this entire system into the Z distribution. So this is known as the standard normal. That's exactly what the normal table follows, which is normally distributed between 0 and 1. So 0 mean, 1 standard deviation. Okay, so let's check it out. So to convert it, we just say, okay, if t is greater than 20, then z must be greater than 20 minus the mean, which is 18, over the standard deviation, which is 5. And that's it. Converting this one, just, well, tidying up a bit, smashing this in your calculator, you should get 0.4. Right. Now, one thing to note is that the table always wants it to be less than or equal, yeah? So if you're not sure how to convert it properly, just always draw the bell curve. You know, just label this part. Let's see, make it easy. Let's say this is 0.4, right? Or in this case, 0.4. What we're actually analyzing here, so let's treat this as a 0, yeah? If this is 0.4, then this part here must be the amount we're looking at. Okay, that's the regions of this part. But what you could also note is that the table only measures when it's less than or equal, so it only looks at this part when it's less than the value. So I always see this as the red region plus the blue region will always give you total probability of 1. Okay, that's the regions. All these probabilities equal 1. Okay, so in this case we have at the moment the blue region. We need to find the red region. So the red region is going to of course be 1 minus the blue region. Okay, or in this case, because we have the blue, we can replace blue as 1 minus the red. That's the one we're going to use here. Okay, so we can just say, instead of writing z greater than 0.4, we can say the blue region is equal to 1 minus the red region, and red is less than or equal 0.4. So 1 minus probability z is less than or equal 0.4. Okay, so that's the main point. Now all we do is just look at table for 0.4. So I'm going to open up now. So where's 0.4? So here's 0.4, so it's like 0.40, so 40, and that's it. So you get 6554. So it'd be 1 minus 0.6554. Yeah, and that should give you 3446. So the solution would be 0.3446. Okay. Another way you could just do this, if it's greater than and you want to flip it, just 1 minus it and then switch the sign. This is identical to that. Okay. Okay, moving on to part B. So it says that the company has a large store of samples analyzed by UTO with the time taken for each analysis recorded. Now, Serena's investigating the samples that took UTO longer than 50 minutes analyzed. Okay, so that's what we're looking at now. Now, she selects at random one of the samples that took UTO longer than 15 minutes. So, okay, so this is already telling us that we're working in 15 minutes. So the sample size would be at least over 15 minutes. Find the probability that this sample took UTO more than 20 minutes analyzed. Now, I don't know if you guys can see, but this is a straight up given that style question. Okay, so we're looking at the given that style problems. Now, how do we know it's given that? Firstly, we know straight away that UTO has already did it. One of his samples took longer than 15 minutes, so that's already done. So if we're to solve this probability now, B, find the probability that sample took more than 20 minutes, or this should be the probability that it took longer than 20 minutes over 15 minutes. That's really what they're asking here. So probability he took longer than 20 minutes, given that that he already took at least 15 minutes. So we're finding like the probability of being over at least the time difference. Okay? And well, we already solved the first one. We already had 0.3446. Now we just work out the z value of this one and pop it back in. So same thing applies. So just like you did earlier, so just be probability of t greater than 15, so be z greater than 15 minus the mean over the standard deviation, which was 5. Okay, put that in the calculator. So 15 take away 18 over 5, you should get minus 0.6. So probability z is greater than minus 0.6. Now, if it says minus there, you just pop it outside and call it 1 minus that probability you just did. That's the easy way to convert it. And again, to convert this back into the less than or equal format, using the idea of the red and blue, you can just replace this one with 1 minus the less than the equal sign. So 1 minus the left side. So then this probability now, let me just get more space, would be equal to 1 minus, and then just put one fat bracket, 1 minus probability that Z is less than or equal 0.6. So actually, 1 minus 1 minus all of this cancels out, so you're actually just getting a probability Z less than or equal 0.6. Well, it's getting kind of slow to load, isn't it? So yeah, actually this is reduced to that. So what we do now is go back to the table, find the 0.6 value here, and see what that gives us. Or look for Z being 0.6. So let's see, where's my tables? Okay, so here's 0.6. So it'll be 7257. 7257. 7257. So this would be over 7257. So this will make more sense when you solve it. So really we're just finding the probability that given that he took longer than 50 minutes, that he also took 20 minutes longer on this run. Or at least he took longer 20 minutes out, given that we know he took at least longer than 15. So it shouldn't be a very big difference probability. So smashing that in, we should get, well, about nearly half, yeah. This looks like, so about 0.47 and round up to 249. So keep it 4 decimal places like the rest of them. Okay, finally, part C. So according to this one, Serena can identify in advance the samples that Yuto can analyze in under 50 minutes, and in future she'll assign these to someone else. Okay, so one thing to be very careful here, she's talking about someone else. In other words, this statement does not apply to Yuto. Okay? That's the thing. In the future, she'll assign these to someone else. So this following statement does not apply. So C, estimate the median time taken by Yuto to analyze samples in the future. If we go back to the previous problem in B, the statement earlier, it states here that she selects at random one of the samples that took Yuto longer than 50 minutes to analyze. We are still referring to Yuto, and even in the previous one, Serena is investigating the samples that took Yuto longer than 50 minutes to analyze. This statement here is just about somebody else. So be very careful not to use the less than 15. Okay, that's just be very careful. It's kind of sad because this is a very tricky trip-up question. So what do they want us to do? Now to find the median time, let's have a look. So it's telling us specifically, and it doesn't matter which order because the median is the 50th percentile, right? The probability I took, the time to be either less than or greater than 15. So I'll just say less than because that's what they usually use. Then let's say the median time. Given that the time we know that Serena wants to investigate Yuto is always going to be greater than 15 minutes. That's how we begin, okay? So this would be the conditional probability. Now, let me just make this m look a bit more clear. Let's use a little m actually. Okay. Now, in this case, what does this mean? So let's go ahead and expand this probability, yeah? So firstly, we know it's going to be a given that, so it'll be probability t less than 15. Now, how about the top line? This tells us that the variable t lies between, which t is firstly bigger than 15 and less than m. So this, we can intersect these two. So putting t in the middle, it will be between 15 and m, because it's bigger than 15 but less than m. So it's between them two, and that's the probability. Okay, and before I continue this one, just remember, both of these firstly equal 50%, so it equals a 50% mark for both of them. Now, we can actually tie this up really nicely. The bottom probability, we can actually resolve it. So probability t is greater than 15, well, we can multiply across, because we know the value of this one is 0.7257. So this would mean, so moving here, we now have the probability that 15 is less than t less than m. It's equal to 50% times 0.7257. So put that in a calculator and you should get, so I got about 36285. Okay, not bad so far. And now at this stage, we can convert this one to the Z form. So let's try it here, yeah? So it'd be probability that we got 15 minus the mean over standard deviation is less than the Z, and then m minus 18 over 5 equals the same probability, 36285. Now, we can quickly evaluate this one. So the cool thing, this one, we can just subtract the differences. So wherever the the function of this one in the table, we can write this one as the IO, not IO, the O should be there, of m minus 18 over 5 equals the IO of this value here, which would be 15 take away 18. So I think we already did this one, isn't it? 15 minus 18 over 5, of course we did, minus 0.6 must equal this probability. So the reason why this will help, because eventually we can make this a subject and we can solve this directly. Now this is the same as 1 minus this, so we're going to have the same term here, m minus 18 over 5 minus, and then maybe I should be very careful, 1 minus this one, IO 0.6. And just what did this one give before? Just always good to double check. Open up the distribution table. 0.6. Well, of course, it gave 7.257. What else can it give? So 7.257. Let me just get back to where I was. That was my 7.257. So it'll be 1 minus 7.257. This will give us exactly 0.2743. Now you can add it to the other side, so then you can make this the subject. So add this across to the other side, plus 36285. Okay, not bad. And therefore you're going to get the IO. I've seen the masking, by the way, and it's kind of confusing how they calculate it, but it seems that they take a lot of steps. So add it across, you should get exactly 0.63715. Okay, so we're almost done this journey, yeah? So far so good. So this is the more convenient way to do it, I believe. Now, all we need to do now is look back into the Z table and find a value that corresponds to this. And then we should be good. That corresponds to 68715. And at this stage, we're done. I believe this should be it. Let's hope I didn't mess this up. Nope, no, it's good. Okay, so let's correspond to 68715. 637, oh my god. 63715. 6, so you just look at the probability, 63715, 637. Okay, this one looks like the closest match actually. So 6375. So this would be 0. So the Z value that corresponds to probability would be 0.35. Okay, perfect. So this means this part here must be equal to 0.35. And that's it. I think we're done. Let's wrap this up. So let's just do it here. So that means m minus 18 over 5 must equal 0.35. Therefore, now this is easy. Now you just solve for m. So times by 5 and plus 18, we should get, yep, 19.75. And I believe this is exactly what they achieved as well. Anyway, guys, I hope this helped. And let me know if you have any questions. I find this methodology a lot easier to work with. Even though it looks a bit, heavy-handed, it's all about just carefully moving things across. The very tricky part is probably the very first conditional property, because it's very misleading. Anyway, the rest of this seems okay. You just make this a subject, times it across. Use your Z values for this one, so convert this to the standard normal like we did here. Resolve it as you always would. Throw this to the other side, and voila, we should be done. Anyway, guys, I hope you enjoyed this one, and I shall see you next time. Ciao. So we're given this x for bi-spinner, and all we need to do is calculate the expected value of x. And to do that, we need to use a probability distribution and multiply that random variable x against each probability. So let's have a go. So for every x, let's start with the first one. So we're going to have 0 times 112 plus, so this will be the first set from the x equals 0, plus 3 times 2/3 plus 6 times 1/4. And that's it. When you evaluate this, you should get 3.5. Literally, that's it, guys. Done. Okay, so that's the general idea. Okay, now we need to calculate the variance of x. Okay, so the variance of x is defined as follows. It is equal to the second moment, so the second expected moment, minus the mean squared. So let's not get confused by notation. So the second moment means that for every single random variable x, we need the x squared equivalent. So we need to make an additional row and call it x squared. So now let's square every value here so we can actually use this formula. So 0 squared is 0, 3 squared, 3 times 3 is 9, and 6 squared is 36. Now all we do is repeat the process. So for ex squared, we're going to have 0 times 112 plus 9 times 2/3 plus 36 times a quarter. And then once we evaluate this, we can just subtract it against the mean squared, which is 3.5 squared. Easy. And that's it, guys. That's literally all you do. And if you enter this in your calculator, you should get 2.75. That's it, 2.75. And that's it for now. Okay, parts C and D. Now what do we have here? So a bias coin has one face labeled 2 and the other face labeled 5. The score Y when the coin is spun has the following distribution. So it tells us that the probability when the coin lands on 5, we get P, and the expected value of Y would be 3. Okay, so C and D, form a linear equation P and show that P gives you a third, and write down probability distribution Y. Okay, first things first, always do the probability distribution first for any question. This is like a must. So I'm going to start with D first, yeah? Now one thing we know is that this bias coin has one face labeled 2 and another one labeled 5. This means that the only possibilities for this probability distribution would be 2 and 5. Meaning the probability of getting this, probability of Y, would be, firstly, we know that probability getting 5 would be P. That means the probability of getting 2 would be 1 minus P. This is because the sum of these two must always equal 1. The sum of all probabilities must be 1. And to get this right, you have to do 1 minus P. Okay, so that's easy. Now, as for the second statement, it says that the expected value of Y is 3. So if we calculate the expected value, we need to equate it to 3. So let's do it here. So the expected value Y is equal to, firstly, Y times PY. So 2 times 1 minus P plus 5 times P. And it must equal to 3. Now, all you do is literally solve this. So let's try and sort it out. So expanding the bracket, you should get 2 minus 2P plus 5P equals 3. 5P take away 2P is 3P. Minus 2 across, you get 1. Hence, P equals a third. This means if we're going to update our probability distribution, what do we have? Let me change color pen. So P here is going to be 1/3. And 1 minus P, so 1 minus 1/3, well, it has to be 2/3 anyway. It has to be 2/3 because the total must give you 1. And that's it, guys. That's all you need to do. Okay, parts E, F, and G. Let's have a look. So Sam plays a game with the spinner and the coin. Each is spun once, and Sam calculates his score S as follows. So just to make it clear, you only do them both once. Okay, so we have to combine them. We need to multiply them once each. So let's have a look at what happens. So if x equals 0, we get this result. Then s equals y squared. If x doesn't equal 0, then s equals x times y. So that seems quite easy. Now, part E, show that the probability s equals 30, then you get 112. Find the probability distribution s, and of course, find the expected value s. Now, as always, I always find it easy to do the probability distribution first, because if you can get this one right, every single thing will be easy to compute. So let's have a look. Let's start with the first condition, if x equals 0. So right now I'm going to draw a probability distribution, a very simple one with s and the probability of s. Okay, just draw a nice, oh my god, that's not even a straight line. And just try and fill it out. Okay, let's have a look. So now when x equals 0, what are the options? You get y squared. This means you have 2 squared or 5 squared. So I'll do this in blue to represent. So 2 squared is 4, 5 squared is 25. Now let's go ahead and solve the probabilities regarding them. So Sam plays a game, and what do we know? Each is spun once. So when x equals 0, I mean you get probability 1/12, then you pick y, whatever letter you get. So if you get y is 2, then you'll be 1/12 times 2/3. So this would be exactly 4/36. For 25, for the y case, when you get 1/12, you 1/12 multiply 1/3, and that'll give us 1/36. So this is quite easy, this one. Be careful not to square these values, because remember, you're only spinning it once, not twice. Even if it says y squared, it means that your final score will be y squared, not the probability is y squared. So that's one thing to take into account. Okay. Now let's look at the second case. Let me just put the red pen. So if x doesn't equal 0, then then the score will simply be x times y. So we have combinations. We can say 3 times 2, which is 6. We have 3 times 5, which is 15. We have 6 times 2, which is 12, and 6 times 5, which is 30. Okay, now for the sixth case, so to get 3 and 2, it would just be 2/3 times 2/3, which is 4/9. To get 15, it would just be 3 times 5, so 2/3, and 1/3 is 2/9. What else do we have? 12, 6 times 2, so 1/4, and 2/3 will make 2/12, so multiply them. And the last one, which is actually the solution for part E, is just 1/4 times 1/3, which is 1/12. Okay, I think the red ones are quite straightforward, but the blue one is a bit tricky. It just depends if you didn't catch this statement out here. Spun once, okay? So just once you use it here, and of course your default is 1/12, because that's when x is 0, we know that. Okay, that's good. So let's move forward. So show that probability s is 30. Well, just to actually show it, just say probability x equals 6 times probability y equals 5. And just fill out the numbers. So this was 1/4 times y equals 5 was 1/3. And that should give us 1/12. Now, last one, part G. So find the expected value of s. Okay, this is just like always. You just do s times the probability. So 4 times 4 is 36. So this will give us, actually, let's just keep it in this format. So you literally just keep doing this. You just multiply up and down, yeah? And you keep on doing this until you get to the final one, which is 30 times 1/12. And you should get about 137/12. And that is the same as, yeah, about, I'm not sure if it's a big deal, but 11.42, 2 decimal places. And here we go, part H. So Charlotte also plays the game with the spinner and the coin. Each is spun once, and Charlotte decides to simply ignore the score on the coin and just use x squared as a score. So that's why I got the x distribution right here. Sam and Charlotte each play the game a large number of times. All right, let's have a look. Now, H, state given a reason which of Sam and Charlotte should achieve the higher total score. Okay, now it gives you a big hint here. It says she uses x squared as a score. This tells us straight away that we need to find an x squared distribution. Okay, so we already know what x is. So let's just go ahead and find the x squared distribution. So we've got probability of getting x. So just keep the natural probability getting x. So all you do is find the x squared. So all we do now is square every term. So the square of 0 give us 0. The square of 3 is 9. And 16 would be 36. Oh, my stomach. Now, how about the rest of them? Well, the probabilities of course be the same because it's the probability of x. Now all we have to do here is simply find the expected value of x squared, and that's fine. So expected value x squared, what is it? It will be 0 times 12, which is nothing, 9 times 2/3, and 36 times a quarter. Now just working this out quickly in our books. Actually, you can do this mentally. So you go 18/2, which would be 6. Cancels out would be 9, so it would be 6 plus 9. So it's actually 15. So technically, it's taking reason which of Sam and Charlotte should achieve the higher total. Well, Charlotte is clever. She's using x squared score, so Charlotte will be getting much higher than Sam's score. So you can say the score of Charlotte is higher. So that's the answer. It would be Charlotte. Okay, reason 15 is greater than the expected value of S. And that's it, guys. I hope this video helped, and let me know what you think. And I hope I didn't confuse you guys on the final part, because actually at this stage my brain is all completely mush. But anyway, guys, let me know what you guys think of this video, and other than that, I shall see you in the next videos. Ciao.